Hi, my name is Martin Krzyżanowski, and in this tutorial I would like to show you how to design tap water installation in InstalSystem 5 package. We will start with some simple project with some simple example. As you can see on the screen now, we have here some single family house with 2 levels. And I have already prepared the building we will use just to design tap water installation. For that purpose, I used some PNG files as a plan views. And here we have 2 levels, so we have 2 stories, ground floor and first floor. On both of them we have some drawings, some PNG files. Having them on plan views, I have created a building structure with walls, windows, slabs and the roof. And it means that we will not start from scratch with the bare project. We'll start from some, let's say, intermediate point of our designing work. If you would like to find out how to get to this point, how to create that kind of building structure, please check our materials on our YouTube channel. Now you can see on the screen our InstalSoft Global YouTube channel. And for that moment, this is common channel for Polish and other languages, but the Polish content will be transferred soon to separate channel. And if you scroll it down, you will find here a playlist InstalSystem 5 webinars and tutorials. And here you have InstalSystem 5 preparation of building structure. In this webinar you will find all steps that are required to prepare that kind of project, that kind of building, with import of most typical files like DWG file, PDF or PNG, and how to create building structure based on these files. And if you have, instead of drawings with plan views, if you have a model of the building in IFC file, in this tutorial you will find all steps that are required to obtain the building structure from IFC file. So let's take a look maybe first on the plan views. This is ground floor, and you can see that there we have some kind of boiler room. There we have a bathroom and a kitchen. And on the upper level, on the first floor, we have a bathroom. And as usual, when we start the new project, we should first check and set general data for the project. So let's first change screen arrangement to general data. And for that moment, we don't see too many tabs here, but first we need to check if we have access to the right module in the program. We will need and use this one, water supply systems. And if you would like to check what modules are available in your program, in your configuration, you may check it directly in the package manager. This is package manager. And there we have help button. And there are 3 tabs: technical support, online help, and video tutorials. There you will see the list of modules available for your configuration, for your license. And if you want to design tap water installation, you need to have that module, tap water systems. And taking that opportunity, let me tell you about possible variants of help to the program. The first one you could already see, video tutorials in our YouTube channel, but you can also use our online help system platform. And for example, here you will find this article, Designing of Water Supply System Installation. And there, step by step, you will find all phases you need to go through to make that type of installation in InstalSystem 5 package. And finally, on this top technical support, you have some buttons, problem with license or activation. If you lose, because of any reason, activation of your license, you can send us that report and we will unlock your license. And if you have some question or you cannot solve some problem in the project by yourself, you can use this form. The file will be attached to the form. You will be able to describe the problem and it will be sent to our support team. Okay, so first we need to check this checkbox, water supply systems. And let's check now what tabs we have and what can we set or what can we modify. First, we need to import or load to the project some databases that will be used to create our tap water installation. And in this tutorial, I use English version, so you will see the content available in English version. We have here different manufacturers. And using different language versions, you will see different databases here, different manufacturers. So the list may be more complex, or you will see just different list of manufacturers. And to choose the proper database, you can choose also one of available filters right here. And you can see that we have, for example, expansion vessel for tap water systems. We have filters and fittings for water supply systems, pipes and fittings. So using these filters, you can limit or just display the particular type of databases. And by using these arrows, you can move some position from the left side to the right side, and this way to use it in your project. And in our project, we will use just some neutral databases without specified manufacturer. So we have some here pipes, for example, copper pipes. We have some insulation and standard water taps and whiteware. The next tab is stories management, and here you can see a number of stories. And for example, for the ground floor, we can check or we can change default pipe run distance from the floor. You can set it separately for hot water, cold water, and circulation. And let's maybe change it for the cold water. We will set it to 0.35. And the same with the first floor. The next tab or group of tabs interesting for us is this one, water supply systems. And let's check one by one. The first one, calculation standards and options. In the first field, when you set the mouse pointer on it, you should see the hint. And this is the maximum temperature drop in the circulation network. The next two, number of hydrants in riser operating simultaneously, and similarly in the network. And finally, you can choose the standard on which the calculations will be made. And we have access to different standards. The first one is the old German standard, DIN 1988. The next one is the newer version of this standard. We have also access to Polish standard and to European standard. And we can choose independent on the version, language version you use, you have access to all the standards. We can choose one of them and design and make the calculations basing on the rules from this standard. There are some additional options right here, but you may not have access to them because they are available in some additional module for the program. And let me once again switch back to Package Manager, and this is that module, tap water extensions. If you have that extra module in your program, you may calculate discharge time by indicating some ending point in the installation. You will be able to calculate the time of hot water discharge. And you can also additionally design ring installations. But this will be presented in the second step, in the second phase of this tutorial. In this case, in this single family house, we will not make that kind of installation. Sources, there we can choose default building type. And there you can see the list of available types of the building. Default cold water temperature, default hot water temperature, and on what elevation we have source, and let's change it in this case to 0.5. And this is some extra setting that comes from this new DIN standard of specifying flows in the network. Flat station, it's worth to mention that we can also use that kind of devices in our projects, and maybe let me show you some ready project with flat stations. It presents some multi-apartment building, and there we have risers with flat stations. They supply heating installation, but also they supply tap water installation. And that's a good example that presents how you can combine different types of installations in InstalSystem 5 package. In this case, we have flat stations supplied from the heating network, and they provide heating medium to hot water installation and also to this heating installation in the apartments. Another tab, distribution system, and the first tab here is types and default data. On this tab we can set default pipe types separately for cold water and hot water and circulation, and for different locations. So we can, for example, choose different material or different pipe type for the last sections connecting ending points, and different materials, for example, for the risers. Program automatically detects by analyzing the network location of each pipe. And let's check it once again on this example, and let's display just the water supply system. And for example, if we click on one of these vertical pipes, you will see that this was detected as the riser. If I click here, you will see location connection line. This one, building unit. And finally, if we go down to the basement and click on one of these horizontal pipes, you will see that this is network. So if it's necessary to distinguish material on different locations, you can do it right here in these fields. You can also set insulation. If you use the same material for all locations, you just choose it in the first line and use this button. This selection will be copied to other locations. We can also set default pipe run surrounding temperature, and it's important to properly calculate temperature drop on the pipe runs. And below we have different valve types. Also, we can choose from the databases some default types of different valve types. There we have shut-off valves, non-return valve, circulation controller, pressure controller, backflow preventer, and finally, depending on what kind of network we will have in our project, we can also choose, for example, manifold, water meter for hot water and for cold water, and filter. Next up, pipes and insulating sizing options. There you can see just the one type we used in common settings, or you will see many different pipes here depending on how many different types you use in your project. For each one you will see available range of diameters, and you can uncheck some of them from sizing if you would like the program not to take it into consideration during calculations. And other parameters like minimum diameter, maximum velocity, minimum velocity, and maximum unit pressure loss. By changing these parameters, especially maximum velocity, you can control the scope of determined pipes diameter. So, for example, if you would like to reduce required pressure in the source, you can limit this value. So a program will reduce the flows in the installation, but in return you may expect that you will get higher diameters in the network. The next up, fixtures and draw of points, and there you can choose from the list different types of particular fixtures: bath tube, WC, wash basin, basin, sink, bidet. You can also define their dimensions, height, this is distance from the floor, and type of water receptor. So, for example, for the basin, we can choose between mixing outlet tap with shower or mixing outlet tap with handheld shower or concealed one. And if there is a frame also in your project, you can choose, if you have proper database with frames, you can choose also frame for all these different types of fixtures. And finally, default connection system, that this selection affects set of fittings determined for each ending point. So it affects the list of materials. And the last one important tab in general data is this one, units. There you can choose units displayed in different windows, in result tables, in 2D view, 3D view, for the pressure, unit pressure drop, and volumic flow rate. We can also define style of presentation, all items on the 2D view and 3D view, but we will skip it now. Maybe we'll change the style a little later. We will finish on this tab. And please remember that if you use the same set of general data for different projects, you may, after changing settings on these tabs, you can save it as a template. And this way you create the template which may be used for your further work. So you can create many templates, and depending on, let's say, building type, depending on height of the building or type of your project, you can have many different templates, and you will not need to, in all cases starting the new project, set all this data again. Okay, so we have checked common settings, we changed some of them, and now we can go to the next phase, and we can go to 2D view and to create our tap water installation on the plan views. Okay, so this way we have reached the next phase of our project. This is plan view of the ground floor, and if we zoom it in, you will see that there's a boiler room, there's a bathroom, kitchen, and in the upper level we have also bathroom. So let's start with the ground floor. Let's change the scope to water supply, and let's first take a look on the ribbon, on the icons we have and we can use in the project. First we have a group of icons, distribution water supply, and starting from the left side we can expand this icon pipe run, and there you will find cold water, pipe run, hot water, circulation, common pipe run, double hot and cold water, and triple cold, hot and circulation, and no medium flow, and also outlet of no flow pipe run. The next icon with sources, and there we have different combinations of sources. Cold water connection, cold water plus hot water, cold water plus circulation plus hot water, and pressure boosting device. The next icon with heater and flat station. The next one with riser. Riser is some common element used in different kind of installations in our software to combine, to connect installations on different worksheets. And also there is another tool, remote connection. Manifold, valves, and you can see the same type of valves we could see in the general data. Fittings, there you will find pump, filter, water meter, safety valve, pressure gauge, thermometer, and expansion vessel. And the next group of icons of items we can use in the installation, fixtures and water taps. And the first one is bath tube. There you will find water closet, toilet bowl, bidet, urinal, wash basin, shower tray, sink, washing machine and dishwasher, and finally some single ending points like cold water supply valve and few more elements. And we will start first with this bathroom. I will move this label beyond the room so we will see this bathroom. This drawing doesn't look perfectly, but that's the, let's say, consequence of using PNG file. And let's start maybe with the first element here, with the wash basin. So I choose the proper icon, click on the default one, and now you can see it in the preview. And when I move the mouse pointer to the edge of the room, there you can see it snaps to the wall. And now it's already on the drawing. We can also display here 3D view, so we will see both 2D and 3D view. I will hide first floor, and now we can look inside this building, and now we can see this wash basin right here. And maybe let's click on it and let's check what data we have in a data table. What can we change, or what we can view in this data table. First, the symbol. The room program automatically detects if there are rooms in our project and they have symbols. Program detects in which room it is located. Type, and we can change it, for example, to double or to other type. So depending on the look of this wash basin, you can choose the proper type. As I said before, when I was talking about general data, if it is mounted on the frame, you can also apply a frame in this case. Distance from the floor, and dimensions. Looking on this plan view, we can make it a little smaller. And move it again. Next we have element style, and finally data that will be used in calculations of this tap water installation. So the first important field is type of mixing tap, and depending on what you choose here, you may see different values of outflow in these two fields. Maybe let's change it, and let's see if it changes right here. Now it's 0.15, but if we use the default one, it's again 0.07. So these values, they come from standard. As you can see, this is normative outflow for hot water and cold water. And we can also change water outlet point type, and it may also influence these values right here. Next important parameters are required pressure in hot and cold water connection points, and by default, as you can see, it's 100 kilopascals, and also maximum allowable pressure, and it's now the default value, it's 500 kilopascals. Finally, connection diameter of these connection points, and system of water outlet points connection. So we could also see it in the general data, and now for any particular connection point, it can be wash basin, it can be shower tray, it can be toilet, we can choose different set of fittings that will be used to connect this water tap to the pipes from the installation. and spacing between connection points between hot and cold water, and that's all. So this is set of typical data we can see for any water outlet point in the project. This one is with hot and cold water. If we use, for example, let's maybe introduce the next one right here, water closet, you will see that the data will be limited only to cold water features. So as you can see, most of the data are applied. They are taken from general data or from the standard. So we don't need to click on each one and enter data at any time we put it on the drawing. But if we want to change this data, we can select this element and we can just use data table to change this data. Okay, so we have two fixtures, and let's introduce the third one. Here we have shower, so let's put the shower tray, and we can change dimensions like that. You will see it right here, and that would be all in this bathroom in the ground floor. And now let's move up to the kitchen, and here in the kitchen we've got two items, two elements used in our tap water installation. There we have sink, and there we have probably we have here dishwasher. So let's put it right here. Okay, so this is dishwasher. You can see it also on 3D view. And there I will put sink. We may change the configuration. Let's take a look here. Sink. Maybe here. I'll check if we have some proper one or similar to this one on the 2D view. It doesn't look exactly the same, but it doesn't matter in scope of calculations. So let's leave it. And finally we go upstairs. In a 3D view we can use this button to change quickly the view. And here I will hide the roof to see what's inside. Okay. And on the plan view I click here, and now I can see the bathroom upstairs. So again, starting from the left down corner, first I will put here washing machine. You can see it on the 3D view here. The next one on the right side is wash basin. On the right side there is toilet bowl, and this time I have to rotate it manually because the snapping mode works close to the wall, and in this case the wall is right here and I want to put it here. So I need to rotate it and do it roughly, just like this. Okay, and finally here we have bath tube, and bath tube is right here. So I do it like this and move it, and now you can see it's also here. So we have all elements in bathrooms and in the kitchen, and we can go back to the ground floor and once again take a look on the boiler room, and we can put here some heater and cold water source connection. I'll start with the heater, and it can be right here. Let's go downstairs also on the 3D view. There it is. We can change size of it, we can change the look on 3D view. Now as you can see, this is storage gas fired. We can change it, for example, to instantaneous gas fired. So now it looks like a hanging gas boiler. And the last and the first also point of our installation is cold water source, and I will put it somewhere on the edge of the wall. And now, having all these items, we have just finished inserting all elements of the installation, and we can go to the next phase of this project, and we will draw all the pipes starting from the source to heater and to the bathroom in the ground floor kitchen, and we will connect it also with the installation on the first floor. Okay, so we can now continue our project with phase number 3. Maybe let's save the project as phase 3. And now we will draw all the pipe runs, starting from the source to all receivers in our project. In the meantime, I've changed also style of some elements. They were transparent, now they are white, so they are more visible on the plan view. And we choose water supply, and we start from the heater, which is right here, and we will first connect or draw the pipe runs in the wall in the bathroom on the ground floor, and next we will go to the kitchen, and we also need to supply the first floor. So somewhere in the wall we will also draw riser, which will supply all these items on the ground floor, on the first floor. So first we take this icon, cold water, hot water, and start in the heater. And we start here, we go up, click here, and we go to the left, click here, and end. And we can also move these pipes closer to the wall. So as you can see, I didn't connect these two elements. I will do it later. And now I will take again the same icon, the same function, start from these points, and go up right here. And again, I will move a little bit these pipes into the wall. I will move them closer to each other. Okay. And now we can connect these elements to these pipe runs. We could do it by using this pipe run, double or single pipe run, but we can also do it automatically using one of the program functions. This function is available here, automatically connect terminal units. But to connect these items, these elements to these pipe runs, first we need to select these elements, and we can do it quickly, just like that. All these pipe runs have been selected, all elements have been selected, and now I can click here, and you will see some yellow sections of the pipe runs. These are some redundant ending sections which were not connected to any element, and if you press delete on the keyboard, they will be deleted. And you can check wash basin, toilet, shower, sink, they have been connected, and also dishwasher. So this way we have very quickly connect all elements in the ground floor, and now we need to provide cold and hot water to these elements on the first floor. To connect these two stories, we will use this element. It's called riser. And we need to put it somewhere on our drawing. I will use this element right here. Enter some symbol. And we'll change configuration because now we have only cold and hot water, but I would like to also draw circulation. So I will choose this variant. Now we've got 3 connection points. And in the data table, we need to change this field. It starts on the story ground floor, but it goes up to the first floor. And now if we switch to the next level, you will see this element here in the wall. So let's connect it. Let's first connect hot water, next cold water, and finally circulation. This is another pipe, another section. Start from the heater and go up right there to this point. And finally, on this level, we need to also connect the heater to the water source, which is right here. So let's use cold water pipe run. Start here, there, there, and let's connect it here. So we have all the pipe runs on the ground floor. And we can go up to the next level and finish our installation with all the pipes that are required to connect all elements on the first floor. So once again, I will use this double hot and cold water pipe run. Go there to the left. And now go up to connect bath tube. And again, we will connect all these elements using this function, automatically connect terminal units, delete these redundant parts. And finally, I would like to also draw the circulation pipe run, this one, starting from this point. I will go up to the bath tube. So it goes here, here, and I will connect it close to this connection point. We can move it closer to the edge of the wall. And now all elements have been connected. We can check if we didn't forget any connection by using this function, check connections. Let's check the diagnostics window. If this yellow window is empty, it means that all connections have been done properly. And we can also check now our installation on 3D view. Let's divide the screen into two parts. And let's check now the installation. Now we cannot see the pipes because they are inside the wall, but we may display here just water supply installation by clicking with right mouse button and choosing the only one visible when active. And now you can see the whole installation: source, heater, dishwasher, sink. On the first floor we have bath tube, washing machine, wash basin, and the toilet. So we have reached another phase. In the next phase we will put on the pipe run some valves, some filters, and we will make the calculations. And before we will calculate this project, I would like to also add some valves, some fixtures into our installation. The pipe runs we draw on the plan views, but the fittings and the valves can be inserted on both 2D view or 3D view. And for example, let's start with the ground floor. And first let's take this heater and we will put there some ball valves and the filter. So I click here, click on this icon, shut off valve, and put it on this time on cold water pipe run. Again on circulation and hot water. And I will also use some filter on the circulation. And again the valve. This is the first place. The next one is that water connection point. And here I will put standard set of elements starting from the valve Next will be water meter. The next one will be again valve. Next, filter. And finally, backflow preventer. And in the same way, we could also add more valves, for example, on this pipe run, connecting the toilet, but we will skip it so you could see how you can put the valves. We used these default settings from the general data, but if you would like to change type of the valve here on the pipe run, you need to just click on it, and in a data table you will find pipe run and also the valve that was inserted on this pipe run. And as you can see now, is the default one. This symbol, this computer symbol, indicates that this selection comes from the general data, but if you want to change it, you may just pick any other from the list. Okay, so now I think we can save the project as phase number 4. And I think we can run calculations. There is some big button on the left side. When you click on it, program will calculate the whole project. And as you could see, it just took maybe 2 seconds. This project has already been calculated. We can check this diagnostics window. It's empty. It means that everything was calculated, no warnings, no errors, no hints. And we may first check results here on a 3D view or 2D view. If you put the mouse pointer on any of these elements, you will see a complex hint with all information about the required flow, required pressure, static pressure, and also about the fittings that were used to connect this tap, mixing tap, with the pipes from the installation. And in the same way, you can analyze the whole model of the installation. If you would like to check the flows in the pipe runs, you can do it in the same way. Just put the mouse on it, and you will also see the flow, pressure loss, temperature in the pipe run, pipe diameter, insulation. And if you would like to check the fittings determined by the program in some particular places of the installation, for example, let's check what T has been determined in this place. You can also move the mouse right here, and you will see that this is 1-inch T and some additional fittings to connect the pipes with this T. So using these two views, 2D or 3D view, you can analyze the installation. And let's take a look now on result tables. With different results. Starting with the first tab, general results, water supply. There you will find some common information about the installation. How many receptors we have, how many pipe runs, length of the whole installation and divide it into hot water, cold water, and circulation capacity, water capacity of the network, and required pressure in the source. Next, we have a table with cold water pipe runs. You can analyze the whole installation. You can see all diameters, the flows, diameter, length, pressure loss. You can find it clicking on this zoom icon on 2D and 3D view. You will also find in this table additional fittings. Same for hot water pipe runs and for circulation. There is also some table with all receptors in the installation. There you can also find information about required flows, pressure, static pressure. This is pressure loss on a route from the source to this selected receptor. And also you can see the surplus of the pressure before this point and temperature of cold and hot water. And on this tab you will find critical hydraulic routes with the highest pressure loss. This is that tab, mixing tab, and we can also display the whole route, hydraulic route, on a 3D view. There you will find icon show critical circuits, and as you can see it's been highlighted in yellow. Starting from the source it goes there, up, and to this wash basin. And next we have more detailed results, all flow paths of cold water, hot water, and circulation. And finally, if you would like to check precisely in details what fittings have been determined on some sections, you can click on the zoom icons and program will select you the pipe run and all the fittings on this pipe run. And the last group of tabs, bill of materials, and there you will find detailed list of materials, pipes and fittings with all reductions, nipples, tees, all pipes, their diameters, lengths, bends. So all the fittings we need to use in this installation to connect all these pipes and all these water outlet points. List of installation, list of valves and fittings, and finally list of assemblies and water outlet points. And all these tables you can just print directly from the program using this button, or you can print it to PDF file, or you can save it to one of these available formats. For example, you can export list of pipes and fittings to Excel file and then process it at basic prices and quickly receive some rough estimation of the installation. So the project has been calculated. We have analyzed results on the drawings and in the tables, and now we can go to final point, to final stage of our project, and we will prepare drawings for printout or for export. So we have calculated this project, we have checked the results, and let's imagine that now we want to prepare these drawings for printout. As you can see, we have plan views of both ground floor and first floor. We have 3D view. but I would like to also have schematic view of this installation. In InstalSystem 5, you don't have to draw parallelly to plan views schematic view of the installation because program will generate it automatically basing on the model of the installation. Let's go to the ground floor and let's generate schematic view of the whole installation. To do it, we need to only put starting point of schematic view, and I will put it on the source, so we will generate complete installation on schematic view starting from the source. And I need to click on this button, generate. And it took few seconds, and now we may first check the diagnostics window. It's empty, so it means that program didn't find any problems while generating schematic view. And now, if you open this window, you will find the first three with plan views and the second with schematic views. And this is that schematic view we have just generated. And you can see the source, all the fittings we used in the boiler room, heater, and one by one we can see all water outlet points. All the pipes, they have labels with information about their diameters. And we can make some modifications. We can move the labels, make some order. Generally, we can very flexibly control the scope of the schematic view by changing configuration of this starting point. In the data table, you will find some parameters, some features of this starting point. And for example, you can decide what scope of installation is presented on schematic view. And also for which elements program automatically add on the drawing labels. So this is schematic view. Let's take a look once again on a plan view. And we will make some modifications. I will display just this water supply installation by changing configuration of visibility of edit scopes. So I choose the only one visible when active. And I will delete these labels of all these valves because there are too many labels and this drawing doesn't look good. So let's delete it. We can add some labels on a schematic view, for example, on maybe on this valve. And if you would like to also have labels on the pipe runs on the plan view, you can add them. For example, or this time on hot water. If you would like to display more information or change the font, the size of the font, we can do it directly in the general data window. Edit styles. and program will switch to general data window to component styles, and here we can control or we can change the configuration of the label. And for example, let's add pipe length. We can also change the font size. Okay. In the same way, we can add labels to other pipe runs on the ground floor and in the first floor. And let's prepare now these drawings for printout, starting with the ground floor. We need to go into printout and insert page. As you can see, by default the page is in vertical orientation, but we can change it in a data table, and we can move this page. You can also change format of the paper, add margins, and generally control the scope that will be printed on this page. There are also these frame features, so by changing these values you can adapt the page to your expectations. And we will also add here drawing chart. This is drawing chart. When it's added in a data table, you can fill all these fields with text. And let's take one example. This is ground floor, so let's enter the name ground floor. With tap water installation in a single family house. We can do it in 2 lines. And the same we will do with the first floor. And with schematic view. Schematic view of tap water installation in a single family house. Let's do it also in 2 lines of tap water. Okay. And if you would like to check the preview of these drawings before printing it, we can display additional window with printouts. This window. And there you will see a group of tabs, graphical printouts. And all these free printouts will be available right here. You can check how it looks before you will print it. And when it's fine, you can just click on print button, or you can print it to PDF. Or you can also save it to one of these formats. It could be, for example, image. So it would be a PNG file. And alternatively, especially when you use as a underlay DWG file, instead of printing the drawings, you can export them back to DWG file. Or if you use IFC file with model of the building, you can export this installation to IFC file. And when you click on this button, export the XF DWG file, you can see the configuration. There are some settings. And after export, you will be able to open it in any CAD application and make some further modifications. And similar with IFC file export. So this was the basic lesson of a quite simple single family house. We've just gone through all the stages, and you could see step by step how you can do that simple example. And in the next part, I will show you more built-up installation and more features that will speed up your work and will let you find out how you can use the program in more complex projects. This time we have a little bigger building, a residential building with 5 levels with the basement, ground floor, and 3 floors with the apartments. And part of the installation in this building has already been done. We can look on it on water supply edit scope. And maybe let's first take a look on the basement. We have here cold water connection point with some ball valve, filter, backflow preventer, water meter, also ball valve and pressure gauge. And there we have a boiler with connection of cold water, hot water, and also circulation with the pump, non-return valve, and ball valves. And there we have expansion vessel, safety valve, also some ball valves. All these elements that were used here you will find in these 2 buttons. Some of them can be placed in the model of the installation on 3D view, but some of them are available only on 2D view. And next we have distribution pipes, and they go up by the risers to the first level. We can go up, and you will see now the installation in 3 of 4 apartments on the first floor. In these apartments, all elements have been connected to the pipes and to the risers, and we will do now also the same in the 4th apartment. So let's go back to the editor, and this is first floor. as you can see, there are 1, 2, and 3 apartments, and this is the 4th one. The fixtures have already been placed, and now we will put this element, riser, and we'll connect all this element with the pipes. So first, click here, put the riser somewhere on the drawing. I put it into the wall. I will change the distance between these pipes to 5 centimeters and change configuration of this riser to cold water, hot water, and circulation. So we will get another connection point of the circulation, and I will enter some symbol 1W as water, and this riser starts in the basement. Next, we can go back to the basement. You will find this riser here, and we can connect it to distribution pipes using this icon of triple pipes: cold water, circulation, hot water. Click here, click on the riser and on the pipes. And next we should also use this element, circulation controller, to balance the flows in the circulation circuit. So let's save this project and let's connect it with all these elements we have here in the bathroom and in the kitchen. This time I will take this icon, cold water, hot water, start from the riser, and we can go inside the wall there, and because there we have external door, we will make some turning point right here, go into the floor, and there we'll go back into the wall to connect all these elements in the bathroom. So click here, click here, click here, and right mouse button ends this operation. Next, I will move these pipes closer to the edge of the wall. And here. And this turning point I will put also into the wall. Okay. So maybe let's draw 2 pipes also here. And now we can connect all these elements, all the fixtures, to the pipes. To do it, we should select this fragment with all these elements, with the pipes and with the fixtures. We can use this icon, select components in rectangle, and when they are all selected, we can use this function, automatically connect terminal units. And the remaining parts of the pipes have been highlighted in yellow. We can just press delete or press this icon to delete them. And let's check the connections. They look fine. Okay. So maybe let's add some valves here at the connection point. We may put some ball valve. We can also add some filter and water meter. And once again, ball valve. I will delete these labels because we don't need them here. And the same I will do on the hot water. So let's start with the valve, filter, water meter, and again valve. Okay, so maybe let's take a look now on the 3D view, how it looks. And to check the proper arrangement of these pipes, we can also display here the construction. And if we select construction and the water supply with Control key and by pressing left mouse key, you will see these two edit scopes, and we can check one by one all the rooms. And if you take a look now on this part of the installation we have just entered, you can see in some places that the pipes are visible, which means that probably we should change the elevation of some sections of these pipes. Maybe let's display here also 2D view. And let's find these pipes. We can click on this pipe, select it, and you will see it on a 2D view. And I would like to put these two pipes into the floor. So to do it, I should first put here some additional points. The first one and the second. And now when I select these two pipes, I may enter distance from the floor minus 0.1, it means minus 10 centimeters. And now they went down, we cannot see them anymore, so it means that they are in the floor. Let's take a look also on these two pipes. We can use this function find inactive windows. This is another apartment, as you can see. To hide these two pipes, we can either move these vertical sections into the wall, or we may just change elevation of these two pipes. And now it looks fine. I cannot see any pipes anymore on the 3D view, so it means that they are either into the wall or in the floor. So let's go back to the previous view. And now I would like to copy this installation on next levels. Depending on the situation, if we have some repetitive part of installation on next levels, as we have in this case, this is second floor and the third floor, we can copy the whole installation, or we may copy just the part of it. If you want to copy the whole installation, first you need to select all these elements. You can use the combination of buttons Ctrl A, or you can use this button, select all. And if you want to just copy the part of the installation, you should use this element to select some fragment of this drawing, and then copy that part with this function. Copy selected elements to the story above or to the story below. In this case, we want to copy the whole installation to the next level, so we will select it all. To see how it is copied, let's again divide the screen into two parts, and let's display just water supply systems with all levels. Now we can see the basement and the first floor, and with Ctrl A I selected all elements on the first floor, and now I will use this arrow up. And you can see that program has switched to the second floor. You can see copied fragment of the installation, and I would like to copy it on the third floor, so I use again the same button. And you can see that when we copy the installation with the risers are automatically extended to the right scope, and they cover all stories where the installation has been copied. This is the first, let's say, function, the first possibility of copying the installation. The second one is available here in the General Data window on a Stories Management tab. If you create the whole building structure, you can also copy the whole story with all construction elements and all the installation that has been already done before. So, depending on the situation, if you have already prepared building structure or you build it together with the installation, you can copy only the installation, or you can just select, let's say, first floor, and click on this button copy. When you use this button, program will copy all the elements, all the installations that are on copied story. And now let's assume that our installation is now complete. We may check it on a 3D view. But before we calculate it, we need to close the circulation circuits. We are now on the third floor. Let me delete these labels. If you want to quickly delete many labels, you can create some additional criterion in the search window. I already have it here, but I will delete it and you will see how to create that criterion. If you click here, add new search, you can choose from the list label. And if you would like to define on what type of element you would like to select the labels, you can choose from the list, but I would leave it as a common criterion. I would like to also have it in other projects, so I will select this checkbox Save in Program Settings. Click OK, and now we have this criterion here. And because I would like to delete all labels that are here on these elements on the third floor, I will choose this button, select this fragment, and now we can delete it. So now finally let's close the circulation circuits. I will do it with this icon, making some return point like this. So I don't draw the circulation to the last most remote fixture. I just make this turning point on the riser. And I need to repeat it in all other risers. The second, the third, and the fourth one. And before we start calculations, let's first check the connections. To check the connections, we should use this icon. And we should now look into diagnostics window. There is one error. With double click, I may select this point and I may quickly delete it. And let's check it again. Now everything is correct. This yellow window is empty. So it means that program didn't meet any problems with detecting the flows, the direction of the flows in the network. Okay, so let's calculate this project. First, we'll take a look on the diagnostics window. Just some warnings. No errors, it means that the project has been calculated. And we may directly go into the results and check some tables. Let's start with general results. You can see number of receptors, total number of pipe runs, total pipe network, total capacity of pipe network, pressure required in the source, and maybe let's check critical hydraulic routes. There you can see all parts of pressure losses, and we can find that receptor in model of the installation and on the plan views. We can also display in the model of the installation the critical route. If the project is calculated, you can use this function show or find critical route. And this critical route will be highlighted in yellow color. You will see how it goes up, and you will find that critical receptor. And in other tables you can check more precisely, for example, some circuits. If you want to analyze in details pressure losses in some sections or some elements used in our installation, you can check it in the tables. You can use this zoom icon to find that element on the plan view and in the 3D view. And finally, here we have list of all the elements of this installation. So let's maybe add now schematic view of this installation. We have the model, we have plan views, and now we will generate a schematic view. So similarly to the previous project, previous example, I will go to the basement and I will find a source of this installation. There we have a cold water source, and there we will put just this element starting point. And click generate. And now we may check. There we have schematic view, and you can check it how it looks. We have all elements. There are too many labels on the pipe run, so we can just hide these labels by changing configuration of the starting point. And in the field automatic labels, uncheck all pipe runs. If we generate schematic view again, these labels will disappear. Now it looks better, it's more clear. And we can manually add labels on some pipe runs. as example, I will add it here, maybe on these 3 pipes. There we have labels, floating label, hot water, cold water, and circulation. The circulation flows have been balanced. In the calculations, program takes into consideration some parameters we set in the general data. First of all, on this tab, calculation standards and options, there you can enter value of allowable volume capacity of the part of installation not covered by circulation. If there is no circulation in some part of the installation or generally in the project, and program detects that this value has been exceeded, you will see a warning in this diagnostics window. And we can also set other parameters like cold water temperature, hot water temperature. And for the circulation, we can set maximum temperature drop. You will see description in a hint. If you put the mouse on this field, you will see a hint. This is, as you can see, permissible hot water temperature drop at most remote point. So it means that in our project, if we take a look back on the 3D view, maximum allowable temperature drop in the riser up to this point is 5 degrees. And we can check what are the valve presets. And that is about that project. In the next part, I will show you some special applications, some special fitting features of the program. Okay, so finally at the end, I would like to tell you something about some features and some functions of the program that may be used in the project to provide proper parameters of the installation and to maintain proper quality of the water in the installation. Let's start with the ring installations. This is some example of ring installation in the apartment. Generally, to be able to calculate ring installations, you need to have access to some additional module of the program. And when you take a look into your package manager and click on this help tab, you will see a list of modules available in your configuration of the program. And to be able to design ring installations, you need to have this tap water extensions module. So this functionality is not provided by this basic module, tap water systems. You need to have this additional module. And what are the rules of designing and calculating these ring installations? The ring must start and end ahead of the riser. So as you can see in this case, it starts here and the ring goes round through these 2 bathrooms. Additionally, we need to have in the database we use in our project, database of pipes and fittings, some additional extra T fittings. And if we have that kind of ring in the apartment, and if any of these faucets is opened, certain amount of the water flows through the left side of the ring and certain through the right side of the ring. So if any of these faucets is opened, we have some circulation of the water in the ring. And it provides the proper quality of the water in the installation. The number and the length of the pipes without the water flow is limited or just eliminated. We also have in the program some extra device. It's called water hygiene station. You will find it here. And this device is produced and provided by some manufacturers. As you can see, it is also connected to the ring. And if this device detects that for a certain period of time there is no flow in the ring, it just flushes some certain amount of the water into the sewage, and this way provides fresh water into the installation. To connect, for example, this faucet to these pipes in this manner, you don't have to draw it manually. You may just select, in this case, a bath tube, select these two pipes, and use some extra function, automatically connect terminal units in a T system. If you do it, program will automatically create proper T connections. And the last element I would like to show you here is the mixing valve. If you connect it with hot water, and with cold water, and next you may connect it with the faucet, you may set in a data table of this mixing valve required value of hot water temperature. And during calculations, program will mix hot water with cold water and will provide water of proper parameters to this connection point. Once again, if you have access to this additional module, tap water extensions, you can make some additional calculations of hot water discharge time to some defined elements in your project. If you select it, you will be able to choose between 4 variants of comfort level. And next, in your project, you may indicate for which elements you would like to calculate this time. There is a checkbox, calculations of hot water discharge time. We may select it for few elements. We can choose this sink and, for example, this bath tube and maybe this wash basin. And after calculations, you will find another new tab, warm water discharge time, with these selected elements. And from this table, you will find out how long it takes to obtain hot water in these elements, depending on location, or rather, or length of the pipes that connects this element with usually circulation connection point. You will also find out what is the water capacity of this part of installation and the flow taken into calculations. And that's all what I wanted to share with you about this scope of the project, about designing tap water installations in InstalSystem 5. Please watch also our other webinars and tutorials about other modules and other types of installations. That's all for today, and thank you and bye-bye.